In this video, I'm going to go through your free response review problems, the calculator questions. So the first one is an area problem. Let R be the region in the first quadrant enclosed by this and the y-axis. Let's find the area of the region R. So we're going to need our calculator. So we're going to plug both of those into our y equals. So I plug these into my y1 and y2. You're responsible for coming up with appropriate window. So we just want the first quadrant. So I'm going to go from like 0, let's just do 0 to 5 and 0 to 5. And if I need to adjust, we will. There's our first one. There's our second one. So I'm going to adjust my window just a little bit. I'm going to go to 2 and 2. Doesn't really matter. What we're interested in is the big deal here is the intersection point. All right, so the area that we're interested in is the area bounded by these two graphs and the y-axis. So this area here. So it's going to be the integral from 0 to this point here. So we need to do second calc intersection. And use, it's free response, so you need to be calculator accurate to 3 decimal places, which means in the intermediate, use as many numbers as you can. Then we just need to figure out top minus bottom. Well, the top equation, the blue one, was my e to the x equation, and then I'm going to subtract the bottom one. Okay, but to avoid any errors, I know this is my y1 and this is my y2. So I'm just going to do the integral from 0 to 0.9419441 of y1 minus y2. Okay, calculator accurate to 3 decimal places would be 0.591 or 590. Both of those are acceptable. Okay, this one, the curve above is drawn in the xy plane, describes this polar curve. So you could graph it in your calculator, but they will typically give you the graph. For 0 to pi, because we're going from here to pi would be there. Find the area bounded by the curve in the x-axis. Well, all of this is positive. So we're going to have the integral from 0 to pi of 1/2 r squared. So theta plus sine 2 theta squared d theta. So you just have to remember that formula. Formula for area is theta 1 to theta 2 of 1/2 r squared. Okay, you just dump this in your calculator and you get 4.382. Okay, the second part of this polar problem, there's a point on a different curve at which the slope of the line tangent to the curve is 4 over pi minus 4. At this point, dy d theta is 1/3. Find dx d theta at this point. Well, we need to understand the relationship that dy dx, which is slope, always, in polar is going to be dy d theta over dx d theta. And then we'll substitute in the parts that were given. So dy dx is going to be this. dy d theta is 1/3, and we are solving for that part. Okay, so we're going to multiply this over and divide by this. So dx d theta is going to be 1/3 times the reciprocal of that. And you can absolutely leave it just like this, or we can simplify it to pi minus 4 over 12, or if you really felt like it, you can type it in your calculator. All right, our next problem is a pretty typical question on the AP exam. It's very calculator heavy, and if you know the rules, then it's really pretty easy. So particles moving in the xy plane, where x and y are not explicitly given, but for t is greater than 0, dx dt is this, dy dt is this. At t equals 0, x of 0 is 4, y of 0 is -4. So the very first thing I'm going to do is I'm going to enter these into my y1 and y2. So this is my y1, this is my y2. It says find the speed at t equals 3. Well, speed is the square root of dx dt evaluated at t equals 3 squared plus dy dt evaluated at t equals 3 squared. So your job is to remember the formula. The calculator's job is to do the heavy lift. So we'll just enter square root. We entered in y1 evaluated at, so parentheses 3, that squared, plus y2 evaluated at 3 squared gives me 3 decimals, 007 or 006. The second part says we want the acceleration vector. Okay, acceleration vector is just going to be the derivative of the derivative evaluated at t equals 3 and dy dt prime evaluated at t equals 3. Again, we're going to use the calculator. So we're going to do the numerical derivative of y1 when x is 3. And I'll just go up and grab that, change y1 to y2. So to 3 decimal places, my answer is 4, negative 5.466 or 467, but make sure you get the 3 decimals. Next, find the slope of the path of the particle at t equals 3. So dy dt over dx dt. So let me back that up. dy dx, just like in the polar problem, slope is always dy dx. For this problem, that's going to be dy dt over dx dt. And we're going to evaluate this at t equals 3. Calculator. y2 evaluated at 3 divided by y1 evaluated at 3. So my slope is 0.032. And then finally, the position of the particle at t equals 3. Well, we're going to have to use our initial condition and the fact that we have the derivatives. So what we want is x of 4, or x of 3, and y of 3. So the integral from 0 to 3 of dx dt is going to equal the x at 3 minus the x at 0. Okay, this part we're going to use the calculator for, and then I'm going to add the x one over. So we're going to have x of 0 is 0 plus this integral, (0 to 3) of y1 is 21. Okay. Then we're going to repeat this for y. So the integral from 0 to 3 of dy dt is going to be the antiderivative, which is y at 3 minus y at 0. So we'll add this over. So negative 4 plus this integral. Scope and snag that. Change that to 0.774. Subtract 4 and get negative 3.226. So my final answer here, my position is going to be 21, negative 3.226. So those are your 3 calculator questions for your response.